Distance and speed questions, when they come up, are normally fairly straightforward, like this one here in 2009. You were told the distance from a point was s equals root t squared plus 1, and you're asked to find the speed when t equals 5. So the only thing you need to know here is that the definition of speed, we'll call it velocity, or v, which is more or less the same thing. Velocity is just a matter of differentiating your distance, so it's ds dt. Velocity or speed is rate of change of distance, so it's ds dt. And now, once you spotted that, the rest of the question is just normal differentiation. And differentiating a square root, some people put it to the power of a half, but sometimes a shorter way of doing that is just to know the rule 1 over 2 root. The other root gives you 1 over 2 root. So 1 over 2 root t squared plus 1. And because of the chain rule, you multiply by the dy dx of what's inside inside the root here, or the derivative of what's inside the root, and you get 2t. The t's cancel, and we just have t over the root of t squared plus 1. And now just put in, this is for any time t, this is the speed, so this is the speed, let's just label it. So there's a possibility of getting confused with letters here. Distance is usually given the letter s in these questions, not to be confused with speed, which is often given the letter v. And speed is the rate of change of distance, which in maths terminology means ds dt. And you differentiate using your normal differentiation methods, and you get this expression here for speed. So speed is t over root t squared plus 1. So after 1 second, for example, you put in 1 for t to get the speed. After 2 seconds, you put in 2, and so on. So after 5 seconds, you put in 5. 5 squared plus 1. So the speed is 5 over 5 5 is 25, 1 is 26, so it's 5 over root 26. And in the question you were given meters and seconds, so it's meters per second is the speed, is the proper unit for speed here. And that's the question done. Just one other comment: if you're asked for acceleration, you just go one step further and you differentiate your speed. So if you had been asked for acceleration, it's just a matter of differentiating speed, dt, or differentiate the answer you got here for speed.